This is the handout for section 3.4, direct variation. And what direct variation means is that you have a comparison between the x and the y, and there's no y-intercept, or the y-intercept is 0. So, for example, right over here, we have this equation y is equal to negative 2x, and our b is 0. Hopefully you do remember the y is equal to mx plus b equation, where the b was the beginning, and that means that this is where we start graphing. Since for our section they will all be 0, we start at the y-axis at 0. So I'm going to open this up just a little bit to remind you that the b is the beginning on the y-axis. So we always start on the y-axis. So in this case it's 0. And then this m was our slope, or our movement. Remember, the changes in y go on top. That means your up and down movement, the rise or the run. The rise or the fall. So, and then the denominator was your x values. That means the left or the right. Because this number is negative, we're going to go down 2. And anytime you don't see the denominator, it will be 1. And a positive 1 means that you go to the right. So we're going to go down 2, 1, 2, and 1 to the right. You can go again, 1, 2, and 1 to the right. Make sure that your line goes through the graph and it has arrowheads at the end to indicate that we can keep going. Let's take a look at this one. Direct variation means that the beginning is 0, so we're going to say plus 0. The beginning is always on the y-axis. And I wrote x-axis. I'm so sorry. This is y-axis. So we start on the y-axis, and that's 0. And then the numerator moves up and down. So this positive number means that we go up 2. And the denominator is also positive. That means we go to the right 3. So up 2, 1, 2, and to the right 3. 1, 2, 3. If we try to go again, it won't fit on the graph, so we'll just leave it at that. Make sure that it goes past your graph, and then you got arrowheads at the end. For the next one, we have y is equal to 0.5x, and you could move a half. That's what you could do. But what I would rather you do is make these into a fraction. Hopefully you know that 0.5 is the same thing as saying 1/2. 0.5 is 1/2. But in case you don't, you could also use your calculator. On these calculators, we have a button. So you can write 0.5 in case you don't know what is the decimal approximation. The fraction for the decimal. You go to math. You hit enter, enter, and they'll give you the fraction for you. So that's 1/2. Why does that matter? Because we still need an up and down movement and a left and right. So direct variation means that the y-intercept is 0. The beginning is 0. So we're going to start at the 0. And now we need to move. A positive 1 means we go up 1. And then that positive 2 means that we go to the right 2. So up 1, And then to the right 2, 1, 2. We can go again, up 1, to the right 2. And that is the graph of the equation. All right, so for this one, we still need to start at the 0. But how do we move? That negative sign can't go in the numerator or the denominator. What I usually do is go with the numerator. That -3 then would have to go down. And then your 4 is positive, so it'd have to go to the right. So we're going to move up 3. 1, 2, oh, sorry, down. Down 3 because it was negative. 1, 2, 3, and to the right 4. 1, 2, 3, 4. Okay, while we have these two graphs on here, I want to make sure that you understand that we could put this negative sign on the denominator. If we would have, it would have been a +3, that means going up, and a -4, which means going to the left. We don't have to do that, but if we did, we would have gone up 3, 1, 2, 3, and to the right 4, 1, 2, 3, 4. Which still makes the same graph. That's important in case you don't have enough space to graph the line. Let me also go back to this one. If you would have done 0.5, what that means is that you would have gone halfway up and then to the right one. Which is still possible. You don't have to make it into a fraction. You just needed to understand what that meant. On the inside, let's go ahead and start on this side first. We have y value is 3 times the value of x. So -3, value of x. And we don't have to graph it the way that I mentioned. What we could do is find values on the calculator. It's already set y equals. So you have -3x. And hit second graph. And I'm going to move it here. And I'm going to start with -2, 6. -1, 3. 0, 0. 1, -3, and then 2, -6. Okay, so we could plot the points. 1, 2, wait, does it go to 6? So we don't need to graph that one. -1, 3, 1, 2, 3. 0, 0. 1, -3, 1, 2, 3, and the other one doesn't fit. We plot our points, we connect them, and graph our line. Make sure you put arrowheads at the end and go past the graph. So this is the way that I have taught you to graph lines. But we still understand that it would be the same thing. We started at 0 for the y-intercept. This meant that we went down 3. And since I don't see the numerator, it has to be 1, which we're going to go to the right. So if we start at 0, down 3, 1, 2, 3, and to the right 1. Still gives us the same line. Remember, like I mentioned before, the negative sign could go into the denominator. So we could have had 3 over -1, which means up 3, 1, 2, 3, and to the left 1. That's how we got the other point. We just need to make sure that it stays in one place and not put it on 2 because that changes the value. The next one, the y value is 2/5 times the value of x. So you have y is 2/5 x. And so I'm reminding you of how to graph it from a table. If I, on a test, ask you to fill in the table, make sure you fill in all the values in, even if we can't graph them all. How you put fractions in the calculators, I recommend that you put parentheses. 2 divided by 5, x. Some calculators don't need parentheses, but rather be safe than sorry. Hit second graph. And we got all kinds of crazy values, like -2 and -0.8. Remember, like I mentioned, you can skip them. So you have -5, -2, 0, 0, 5, 2. And if I ask you to fill in the table, please do so, and it really doesn't matter which points you use. So for example, 6, 2.4, and 7, 2.8, as long as they're correct. You wouldn't want to graph those. It would be hard to graph those. So from here we go -5, 2, 3, 4, 5, and then down 2, 0, 0, 5, +2, you make your line. Okay, so we know that the slope was 2/5, but sometimes it doesn't fit the slope that we have as a positive, or it's not convenient to move in that direction. So we could also do -2 divided by -5. Don't forget a negative divided by a negative is a positive, so the value is still the same. We didn't change the value. But why is that important? From that intercept, we also could go down to and to the left 5, giving us that point right there. All right, this one over here. The total cost C of gallons is 3 times the number of gallons. So we got the cost is 3 times the number of gallons. I wanted to do this problem with you because this is still a y value and this is still an x value. Why does that matter? On your calculator, you cannot put a G in or the G will not be read correctly. So you still have to use x and y values. So 3x is how you put it in the calculator, even though it'll say G. Hit second graph. I'm going to start at the 0, 0. 1, 3. 2, 6. 3, 9. 4, 12. We'll start at the 0, 0. 1, 3. 1, 2, 3. 2, 6. 3, 9, 6. And we graph the line. So in this case, it's very important to know that the negative values don't work. They don't work because we can't give gallons back to the gasoline station. They won't give us money back for gasoline. So that's why we don't have any negative numbers here. That's why this line also starts right there and doesn't have an arrowhead at the end from this direction. but we can get a whole bunch of gallons of gasoline in the positive direction. So to remind you of the y is equal to mx plus b, we still have that we start at the 0, making a direct variation because that y-intercept is 0. And moving up 3, 1, 2, 3, and to the right 1. Up 3 because it was positive, to the right 1 because it's negative. All right. The total cost C of bulk jelly beans is 250 times the number of pounds P. So C is the cost of 2.5 times the pounds. So don't forget, this is still an X and Y value. These would be your X's, this would be your Y's. Why does that matter? Because in your calculator, you would have to put the X, 2.5X, hit second graph. And I'm going to start at the 0, 0. 1, 2.5, 2, 5, 3, 7.5, 4, 10. Those decimals are not easy to graph, so we have enough points that we don't need to graph them. We start at the 0, 0. I'm going to skip 1, 2.5. I'm going to go to 2, 5, 1, 2, and then up 5. 1, 2, 3, 4, 5. Skip that one. Let's see if it fits. 4, 10, 3, 4, 5, 6, 7, 8, 9, and we'll just pretend at 10. Make the line, make the arrow at the end. So candy also, they won't give us candies. Give us money back for candy, so it won't be negative. We can't return it and get our money back. So these are just the positive numbers that we're looking at. So back to the slope thing. This is important. We didn't have the slope, so this is where we could have just done the 2.5 as a fraction. So that's 2.5. Math, enter, enter, 5 halves. So this is the same thing as y is equal to 5 halves x, where you have to go up 5 and to the right 2. 1, 2, 3, 4, 5, and to the right 2. Still gives you the same point as writing it as slope intercept form as opposed to graphing points.